Alright, so this is going to be the grind 75, problem number 1, 2 sum, and this is going to be the solution. And normally I will start off these videos with an attempt, but I have done this problem before, so a genuine first attempt was not able to be made or recorded, I guess. So we're just going to go over the solution. So the brute force solution to this problem, which I haven't actually given the description of yet, so let me do that. So we're going to look at it really quick. Give me a second. Okay, so given an array of integers nums and an integer target, we're going to return the indices of the two numbers in nums such that they add up to target. This is a great first example. We're going to see that 2 and 7 add up to our target, and we're going to want to return their indices. Okay, and the brute force solution to this problem is to check every number against every other number every time that you get to that number. So what I mean by that is, say we start off with 2, and we want to check if there is some target value 9. The way we would check this number against every other number is by doing 2 for loops, where we would iterate over this, and then we would say inside of that for loop another for loop, which would again iterate over that. So then we would start on this value, compare it to every value in this list, and then increment the overarching for loop, again compare it to every value in this list. We could also start a bit later, because the first iteration of the outer for loop started us here. When we move on to the second iteration of the outer loop, then we don't need to compare against this value again because we've already done so. But this is pretty expensive. It'll be n squared, where n is the length of nums, and they actually ask us in the follow-up if we can come up with an algorithm that is less than that. So my approach when I was doing this problem was to do some kind of two-pointer thing, which had us sort the array first using just some built-in sorting function, which I don't even really know if you can do that in problems, just do dot sort. But Java's built-in sorting function uses something along the lines of quicksort, which would be O of n log n. And I think that was actually the bottleneck in the algorithm, because once it was sorted, what I would do was I would have pointers on the front and on the back, and if the sum was, say, greater than the target, then I would move this pointer over here, and if the sum of these two values was less than the target, then I would move this pointer here, and that operation would potentially be n, but with n log n as the largest operation, that would mean that our algorithm would still be n log n. And so while I used that approach, there's actually one that's a lot better, and just a testament to why hash maps are probably one of the best data structures in terms of minimizing cost. So the optimal solution actually is to do a single pass of the array, and basically each time we come across a value, we're going to add it to our hash map, and any time that we want to check if the current value we are at has a corresponding value that will sum to the target, all we have to do is look at the hash map to see if it's there, and then grab the appropriate index and then return both of them. So I'll actually show you what I mean. So we're going to start off by doing the appropriate steps, and let me make sure I'm on the proper screen. Yes, so we're here. So the first thing we're going to do is create this hash map, and then we're going to iterate through our nums list. This is nums right here. Okay. We're going to look at our first value, calculate its difference, which would be 4, and check if our difference is in the hash map. And if a value is in the hash map, that means that we have already seen it in our nums array. But since 2 is the first value, we haven't seen anything else. So all we're going to do is add it, and we're going to add the value itself, or the element in nums, as the key, and they're going to add its corresponding index as the value. And then we're going to move on to the next one. So I'm just going to cross this off. 7. The difference that we want in order to achieve the target value would be -1. And as we can see, -1 is not here. So all we're going to do is continue and add this element to the hash map. So 7 and index 1. Okay, we're going to do the same thing. Just going to cross it off. What target value do we need? 11. So we need -5. Yeah, -5. And we don't see a -5 in our hash map. So then we are actually just going to add 11 and move on. Cross this off, add 11 and its index, and then move on. All right, and then with this value, we know that the difference we need in order to achieve the target is some value of 7. And we're going to check our hash map, which is a collection of all of the elements that we've seen before, and see that there is in fact a 7 here that we can add to our current value of -1 to achieve the target. And as per the rules of the problem, what we actually want to return is the indices. And that's why we have the indices as the value, so that we can return it just in constant time. And we have the index right here of the current value because we're iterating through the list just using a regular for loop. So I will show the code implementation, and it's going to follow this exact logic. So let me switch screens. Okay, that went a little too high. Let me see. Okay, so this is the solution in Java. So as we said, we're going to start off by creating a hash map. It's going to be empty. It's going to have integers where the key is the element in nums and the value is the corresponding integer. Then we're going to iterate over nums, and we're going to grab the element at the current index, and then we're going to get that difference that we talked about. And basically we're going to look to see if that difference is in our hash map. And if it is, then we can get that difference's value, and we can return the current index we were at. Because we know that the difference plus our current value will sum up to our target. And what we really want to return is the indices of those two values. But again, if that's not the case, then we're going to want to make sure to add the value to the hash map, because it could be the case, like it was in our example, that 7 was in fact one of the values that would eventually add up to our target, but we weren't able to find that out until we had gotten to the corresponding difference value. And so that's why we have to keep track of all of them. And that is the solution to 2-sum. This will take O of n time because we are iterating through nums once, and we are adding values in constant time and checking against them also in constant time. And I guess in the worst case, it would also be O of n space because we would have had to add every value or almost every value from nums into the hash map. So O of n time, and I'm pretty sure O of n space as well. So that is the solution to 2-sum in Java.